Good morning all. Here we are again. And what are we going to do? We're going to analyze the input circuit of the Allen Bradley input module, catalog number 1791-3280. I have that circuit breadboarded so we can easily look at the waveforms. The waveforms coming in from the 120 volts AC side and the waveforms going out on the optocoupler output side. So we have two oscilloscopes here. We're going to look at the high voltage side, the 120 volts AC side with this oscilloscope, and that oscilloscope over there is going to look at the low voltage side of the output side of that optocoupler. Now on the output side of the optocoupler I have this power supply providing 5 volts to that circuit. Over here we have 120 volts AC single phase into that circuit. Now down here, let's take a look at this real quick. Down here is the circuit that I've breadboarded. Here's the circuit that we have breadboarded. Now the AC input, the 120 volts AC, enters the AC inputs of this bridge rectifier through these 27 kilo ohm resistors. And on the positive side of the bridge rectifier, if we didn't have this circuit right here, let's take that circuit out for a minute, ignore that circuit. You would have, if you looked at this point right here, the positive output of that bridge rectifier, reference to the ground side, the negative side of the bridge rectifier, you would have pulses, sine pulses, but they would look like this. Let me draw this in here. They would be going positive, like that right there, and this would be your ground. And the frequency, since we have 60 hertz coming in, the frequency at this point right here would be 120 hertz. Now let's add the circuitry back in. We're going to look across the Zener diode as from cathode to anode and look at its waveforms. Then we're going to look at the input LED of the optocoupler. So we have these positive going rectified AC dropped across this Zener diode, 33 volt, and then dropped across this 3.3 kilo ohm resistor. And what we'll have here are just little itty bitty square waves because we're dropping across this LED right here. Now, on the output side of the optocoupler, here's our 5 volts DC and our ground of that power supply. When photons are emitted from this LED, they hit the base of this phototransistor, causing it to go into conduction, into saturation. And so at this point right here, we'll be looking at, with the oscilloscope, the collector of the phototransistor would be pulled to ground. So we'd have pretty much 0 volts right here. In the perfect world, it would be 0 volts. When this LED is turned off, there's no photons hitting the base of that phototransistor, so the transistor's turned off. And we go high through this 4.7 kilo ohm resistor up to 5 volts DC. So on is at ground, off is at 5 volts. Looking at that oscilloscope right there, channel 1. We're first going to look at the input side of that optocoupler. Look at those waveforms. Let's get close to that fluke oscilloscope. The first thing we're going to look at is that 120 volts AC coming into our circuit. There it is right there. And you can see that that is 60 hertz. Whoops, slipped off of it. That is 60 hertz right there. And a peak of about 170 volts on the positive side, 170 volts on the negative side. The next thing we're going to look at is the voltage across that Zener diode. So let's bring this down a little bit. Let's see what it looks like right there. Putting the positive on the cathode of the Zener. Whoops, get on there. I'm putting the positive on the cathode of the Zener, positive lead, and the negative lead of that oscilloscope on the anode side. And you see those pulses right there. And we're at 120 hertz on this side of the bridge rectifier. Now, what we'll look at is pins 1 and 2 of that optocoupler. 1 and 2 of that optocoupler. Let's bring the voltage down a little bit more. Oh, going the wrong way again. There's 1 volt per division right there. Let's see if I can get on it without shorting anybody out. Okay, I'm going to bring that trigger point down so we can get locked into that signal. Okay, I'm putting the probes across that 3.3 kilo ohm resistor, and there again we have that square wave again, much like we saw across the Zener, but this time a lower voltage across pins 1 and 2 of that optocoupler. Still 120 hertz. So if we're seeing 120 hertz on the input side of the optocoupler, that means we're going to see 120 hertz on the output side, the 5 volt side of that optocoupler. So we have a peak right here of 1 volt. Now let's go take a look at the output side of the optocoupler. But now we see why we have square waves on the output side. It's because we have that rectified DC on the output side of that bridge rectifier. Here's our 5 volts peak. Now that's with no 120 volt AC on L1 and L2. That input side of this circuit is turned off. So we are seeing that 5 volts pulled up to the power supply through that 4.7 kilo ohm resistor. Now when I apply 120 volts AC to the L1 and L2 input of this circuit, there's our pulses. There is our pulses. Look at that. So when the optocoupler is turned on, let me see if I can get this to trigger. I gotta get this to trigger so we can talk about it. Let's go to AC line. Let's trigger on the AC line. There we go. That's locked in pretty good. Okay, so when that phototransistor is turned off, we have a peak of 5 volts. When the phototransistor is turned on, it's pulled to ground right here. So off, on, off, on. Let's see if we can look at the frequency. Let's turn that off. go to measure, and let's select frequency. There we are again. I don't know if you can see it, but here it says 120 hertz. 120 hertz. So these square waves frequency is 120 hertz. All right. I hope this clarifies why we had pulses on the output of that optocoupler going into the Allen Bradley microcontroller. Y'all, if you can, breadboard that circuit and experiment with it. Just make sure your scopes are isolated from earth ground, and that way we won't have any high voltage go through your oscilloscope and kind of destroy it. Let me show you how I isolate my oscilloscope. I'm going to turn this off. Turn that off. But you can go down to your hardware store and get you one of these plugs. Let me take this off if I can. Okay, right there is the earth ground prong. And what this does, it disconnects that earth ground prong from your oscilloscope. Or you can use a 1-to-1 transformer. 1-to-1 transformer would work just as well. When you do lift your oscilloscope from earth ground, be careful. Don't touch no metal on your oscilloscope, especially around the probes and whatnot. You don't want to get shocked. All right, all. Have you a good day. Have you a good day. And I thank you very much for coming by and helping us experiment with this circuit. I hope you enjoyed that. I certainly did. Okay. Well, we'll see you next time.